Hi there, this is Penelope, and this is MG5004 Trimester 2, 2016, the last two exam questions, questions 7 and 8. So we're now up to the differential equations question for question 7, and the first part of it for 4 marks is reasonably simple. You've got the derivative on the left-hand side, and on the right-hand side you've got the variable that matches this one, so it's quite easy. We just have to integrate. So we find the derivative first, we go back one step and we integrate t to give us t squared over 2, and then we integrate negative 3 e to the 3t to give us e to the 3t plus some constant, it doesn't matter what you call it, and then you repeat that to get the function x of t. So you integrate again, so that would be t cubed over 3, but it's already over 3, so that goes over 6, and then the integral of e to the 3t would be negative e to the 3t over 3 plus, now a itself has to be integrated, so that would be at, and then plus some other constant. Again, you can call it what you like. Now for part B, we need to use the integrating factor method to solve the differential equation that's given. But first off, we have to clear this bit here. So we need to divide everything by x. So that gives us dy by dx minus y over x equals 1. So then we can say, well, p of x equals 1 over x and q of x equals 1. Now to find the integrating factor, it's going to be the e to the power of the integral of px, so the integral of 1 over x, which is of course, oops, that shouldn't be up there, oh yes it should be, which of course is x, so all of that becomes x. So then we've got mu times y equals the integral of mu times q of x. And the right-hand side is the integral of x. Now q of x is, here it is, here it's 1. Don't need to put it in. And that is x squared over 2 plus some constant. So on the left-hand side, mu was x, so that is xy equals x squared over 2 plus c. Nearly finished. We need to find y. So y is equal to x over 2 plus c over x. Now we're given some information this time. We're given the information that y1 equals 2. In other words, y equals 2 when x equals 1, so that means we need to put those in so we can actually find a value for c. So 2 equals, now x is 1 over 2 plus c over 1. That tells us, we can work that out, rearrange it, that c is equal to 3 over 2, and y is equal to 3 over, oops, did I see, what am I doing, x over 2 plus c over x, so 3 over 2x. Now we could have recognized a little bit earlier that the left hand side is the derivative of xy, so we would have then had the derivative of xy as being x. So then we could say, and it just is the same thing, that xy is the integral of x dx, and it would have led us into exactly the same place. For this one, we're looking at two things. We've got the information about the volume, and we've got the information about the area as well. Let's just have a look at it first, and then I'll scroll down so we don't have the question there. We're looking for the requirement to use the least expensive piece of cardboard for production, because we want to minimize, there it is there, we want to minimize the amount. but we are told the volume. So we've got the volume here, but we're talking about the surface area. So we've got the information about the volume, but we're actually talking about minimizing the surface area, because that's the amount of cardboard that we need to minimize. So looking at the diagram, we can work out that the area of it is 4b plus 5, and then in the other direction it's h plus b plus 10. So you've got the 10 millimeters, 5 top and bottom, and in the horizontal direction you've just got the 5 millimeters overlap. Now let's write the statement for the volume. The volume is, if we do it in millimeters cubed, we'll have 1136,000. It might suit our purposes, and we can work that out as being, I don't know what happened there. The volume would be hb squared, or b squared h. Now, if we look at our statement here, we have b's and h's, so it would make sense to say that h is equal to something and rearrange the volume statement. So 1136,000 divided by b squared is h. So now we've got a volume statement that we can have just in terms of b. So it would be 4b plus 5 times, now it gets a bit messy looking, but it's not terribly difficult. So we've replaced h with that term there. Now, to find b that minimizes this, we need to find the derivative, but I think it would be easier if we multiplied that out. So we multiply it out, and we're going to get, just bear with me a minute, so all I've done there is multiply out. I just was a bit careful, and then I need to differentiate. And I'm differentiating with respect to b, and I'm going to tidy it up so that I end up with powers of b in the descending order. So I'll kind of start here. So it would be 8b plus, joining those together, 45 minus 4544000 over b squared minus 1136,000 over b cubed. Now, to be the minimum, that's got to equal 0, which means we're solving, well, that's a bit nasty. So what if we multiply everything by b cubed, and then we can get rid of our fractions? So we can then find 8b to the 4 plus 45b cubed minus 4544. Now, it just tells you in the question that that has a root of b equals 81.8. Now, if it didn't tell you that, then you would use Excel or your calculator, whatever, to find b, and if b is 81.8, then h is 169.8. And then the dimensions of the carton, because that's what the question asks you. So it'll be 81.8 by 81.8 by 169.8, with millimeters at each step. The last part of this question is relatively straightforward. You're given the formula for the volume as a line is rotated around the x-axis, so just choose carefully, make sure you've got the right one. So it's the integral between a and b of pi y squared dx. Put the pi at the front, and in this case you're integrating between 2 and 5 of the square root of x minus 2 squared with respect to x. So we can square that, means getting rid of the square root sign, and do the integration, and then we have x squared over 2 minus 2x between 2 and 5. Number crunching there, leave it in terms of pi if you like, or you can leave it as the number. But if you leave it as in terms of pi, it does kind of help for the next question when you're finding the centre of gravity. Now, the centre of gravity for this particular shape as it goes around the x-axis is going to be some number x, but y is going to be 0 because it's going to be symmetric about the x-axis there, so y will be 0. So all we need to do then is look for the formula for x. But the textbook actually rewrites it, and it doesn't matter if you don't get this, you can just do the extra steps. But it's useful to know that actually that's what the textbook says it is, but because we've already found v was so if we make use of that, we can actually save ourselves some time. But if you don't remember that, it doesn't matter. But let's just, for the sake of this video, say that we do. So I've got pi, I'll write it down here, pi over, now v was, well, left in terms of pi, said it might be useful, 9 over 2 pi times the integral between 2 and 5 of x times y squared, and we'd already worked out what y squared was. It was x minus 2. So we can cancel the pi's, and we can get 1 over 4.5 times the integral between 2 and 5 of x squared minus 2x, which is, given that I'm going to do it by the calculator, I didn't need to invert my fraction or anything like that. I can just leave it like that for the moment. Now the integral of that would be x cubed over 3 minus x squared between 2 and 5. And by my calculations, that is 4. So the centre of gravity is the point 4, 0.